Over the past few years, a low-flying, slow-moving dive bomber known as the Shahed 136, or the Garan 2 in Russia, has been routinely striking military bases and skyscrapers from the Middle East to Ukraine. While its explosive payload causes significant damage, the drone's most disruptive feature is found in its manufacturing costs. This chart shows the estimated cost of a single Shahed drone, roughly $35,000 to $55,000, compared to the price of a standard U.S. interceptor missile, which sits at $2 million and extends far off the screen. To protect their airspace, the United States and its allies are forced to fire highly advanced multi-million-dollar interceptors from systems like the Patriot missile battery just to shoot these cheap drones out of the sky. Iran and Russia exploit this massive price gap using swarm tactics. They launch hundreds of these inexpensive drones at the exact same time to deliberately overwhelm radar networks and drain the defender's missile stockpiles. This creates a significant imbalance for the defender. For every multi-million-dollar interceptor fired, another $35,000 drone is often already in the air. This forces advanced militaries into a cycle where they risk depleting their specialized missile stockpiles faster than they can replace them. You have to ask how a flying weapon built from commercial parts and a wooden propeller manages to slip past billions of dollars in modern military radar. The propulsion system is surprisingly primitive, a 50-horsepower petrol engine, reverse-engineered from a German hobbyist motor. Yet its aerodynamic delta wing design is incredibly efficient, providing lift for heavy explosives while remaining resistant to wind gusts. This cross-section schematic shows the interior of that delta wing. It is built from a hollow, honeycomb-like matrix of hexagons that scatter incoming radar waves instead of reflecting them back. This lightweight structure also leaves enough room inside to hold fuel for a 1,500-mile flight. For targeting, the drone bypasses complex jam-sensitive military arrays entirely. It relies on a commercial-grade GNSS receiver, a global navigation satellite system that functions essentially like a non-American GPS, to follow pre-programmed coordinates directly to its target. All of these simple elements combine to exploit a specific gap in Western air defenses. High-end radars are calibrated to track fast, high-altitude ballistic missiles. A slow, low-flying object made of radar-scattering materials glides right under their detection threshold. Because the Shahed is assembled using basic commercial microchips and petrol engines, traditional international arms sanctions are virtually useless in stopping its production. Iran has successfully exported the manufacturing blueprint to Russia. Huge new production hubs have been built deep inside Russian territory, completely insulated from immediate retaliation. To meet the intense demand of the war, these factories rely on harsh labor economics. Reports indicate Russia is utilizing teenagers and coerced foreign workers to churn out thousands of units every year. Once built, the drone requires almost zero logistical footprint. It runs on regular gasoline, launches from a civilian pickup truck using a tiny, undetectable rocket motor. The Shahed represents a decentralized method of war. It completely bypasses the traditional military-industrial complex, allowing anyone with a garage and a toolshed to assemble long-range precision strikes. Ukraine has become the primary testing ground for these tactics. Russian Shahed swarms have relentlessly targeted power grids and residential buildings, forcing the Ukrainian military to find an immediate tactical answer. After burning through their own limited supply of Western interceptor missiles, the Ukrainians recognized the economic reality. A cheap drone swarm can only be defeated by an even cheaper drone swarm. Soldiers on the front lines began assembling their own interceptors. They built FPV, or first-person view, quadcopter drones using exposed circuitry and commercial parts right in the trenches. One of these models, known as the Sting, costs only $25,000. It flies up to 200 miles per hour and uses artificial intelligence, or AI, for terminal guidance, locking onto a Shahed and physically ramming into it mid-air. This animation shows the economic scale tipping in favor of the defender. By using a $25,000 interceptor to destroy a $35,000 weapon, Ukraine inverted the entire financial logic of the drone war. This single tactical shift has created a massive geopolitical ripple effect. Wealthy Gulf states and even the United States military are now approaching Ukrainian leadership to purchase these cheap interceptor technologies to defend their own borders. The success of the Sting drone shows that the cost gap can be closed. In modern conflict, the strategic advantage is moving away from those with the most sophisticated single weapons towards those who can produce and deploy low-cost autonomous systems at the highest volume.